Okay, hello, good evening, everyone. Happy Friday, happy Tuesday. All right, wow, everyone is here today. What a rare occasion that everyone is here. Okay, hello Jaden, hello Ajun, hello Charlene, and hello Jason. Wow, everyone is here. I'm very happy today. All right, so guys, welcome. So where were we? I think we were halfway through our chapter 12. Okay, hope we can finish this by today. Okay, so for those who were not here yesterday, last week, okay, I think, is there anyone here last week? Sorry, I couldn't recall. All right, anyway, last week we went through this chapter called sound, if you still remember. Okay, your sound. And then your sound is produced by vibration. Okay, vibration will produce sound. All right, and then sound, as you know, they need a medium to travel. All right, that means they cannot travel through vacuum. Like I said, when you see any, if you watch any space movie, when you see explosion, you will not be able to hear explosion. Okay, the explosion should be silent, but then again, that will be a very boring movie. Okay, so it doesn't happen. All right, so anyway, so they need a medium to travel. They travel fastest in solid because the atoms are very close together. The vibration goes very easily past to next each other. And then gas is the slowest because gas, they are very far away. So very hard for them to pass the vibration. Okay, so if you do this experiment, you will know lah. So when you switch on the bell, okay, when you switch on the bell, you can hear the bell sound, but when you switch on the vacuum pump, as they slowly suck the air out, this thing will slowly become no more noise. Okay, no more sound. Because as this thing become vacuum, you will not hear anything. All right, so sound needs a medium to travel. Okay, so when we talk about sound wave, we need to talk about two things. We need to talk about how high they are. That's the amplitude. We need to talk about how long they are. That's the wavelength. All right, so the amplitude determines the sound or the loudness. Okay, amplitude determines the loudness. So small amplitude, short wave, okay, very short wave. That means very soft voice, okay, very soft noise. If it is a very high wave, it is a very loud noise. Okay, high amplitude means higher sound. All right, so when you are adjusting the volume button, okay, when you're adjusting the volume, you're adjusting the amplitude. Okay, anyway, so the next one would be your wavelength. Okay, your wavelength. As you can see, wavelength is long. That means the frequency is short. Like I said, wavelength and frequency, they go in reverse. Okay, wavelength and frequency, they go in reverse. So long wavelength, low frequency. Okay, short wavelength, high frequency. Okay, so frequency will determine the pitch. Pitch means the you know how high a sound is or how low a sound is. Okay, like it's high pitch, and then it's low pitch. So this is low pitch. Okay, very bassy sound. This is high pitch. Okay, so it's your treble sound. All right. So how do we detect our sound wave? Okay, we detect our sound wave by using our ear. All right. So we have our ear canal here. Your eardrum will detect the vibration, and then the three small bones, which is the ossicle, they will amplify the sound, and then they will pass it to the cochlea. Cochlea is this device here, and then inside the liquid, they will vibrate, and then they will send a signal to your brain. Okay, so this is how you hear something. And then our hearing limitation. Okay, hearing limitation. Our human can only listen to 20 to 20,000 hertz. Have you go and do the listening test? Have I told you this last week? Okay, your hearing test. Okay, have you go and test this thing? Have you go and test how old or how young your ear is? Okay, so they will play you a range of sound. Okay, like I said, you can go and do this. They will roughly tell you how old your ear is. Okay, roughly lah. So you are still very young, so your ear should be very young. Unless you listen to loud music all the time, you use earphone all the time, then that wouldn't be very good for your ear lah. Okay, so I think I mentioned this already. As for, okay, our frequency will decrease as we age. Okay, that means you won't be able to hear this range when you are old. This is for young people. When you are old, you cannot listen to like 20 to 20,000 really, because it's, you know, you're old, your ear is becoming less and less sensitive. Okay, so anything above 20,000, we call it ultrasound because we cannot hear it. All right, those are, you know, for like dolphins and bats. Okay, dolphins and bats, they will use something called ultrasound. All right, so let's talk about ultrasound. Okay, I think we stopped around here last week. Okay, let us finish this and then we can go to exercise next week. Okay, I mean later. All right, so our human hearing and limitation, as I said, 20 to 20,000 is the one that you can hear. I think dogs are slightly better than us. If I'm not mistaken, dogs are around 40 to 40,000. That means a dog's hearing is almost twice of our hearing. All right, ours is 20 to 20,000. Dogs is 40 to 40,000, like twice of our range. This is why dogs can hear better than us. All right, especially certain dogs are like, for example, the Doberman. Okay, for example, a German Shepherd. Okay, like Border Collie. Those dogs are very good in listening, so they have even more sensitive hearing. This is why I don't know whether you notice this. If you have a dog at home, you will notice that your dogs they can hear things better than you. Okay, what do I mean? For example, if I buy something from Shopee, because I live in a flat, I live in a condo. Okay, I live in a condo. Whenever the Shopee guy is coming, okay, even I cannot hear anything, but my dogs will bark first. Okay, my dog will know, she can recognize the Shopee guy's footstep. So when she starts barking, I know the Shopee guy is coming. Okay, because I cannot hear anything. Because dogs, they have very sensitive hearing, because they have bigger range of hearing. We don't. All right, so this is why humans, we use dogs as our companion in hunting, because they are better than us in, you know, hearing. So that's the thing. All right, so if you look at dolphins, they're much better. They're like 75 to 150,000. That's like 4 times better than dogs. That's like, I think, around 7 times better than humans. That's a pretty amazing hearing. All right, so this is dolphin. All right, so ultrasound, whenever it's above 20,000, okay, because we can only hear from 20 to 20,000, right? Okay, this is our limit. This is our hearing limit. Anything more than 20,000, this is what we call ultrasound. What does it mean by ultra? Ultra means higher or more or better. Ultra. Okay, ultra. So ultrasound is the sound out of our hearing. We cannot hear ultrasound. So dolphins, bats, they do ultrasound. Okay, even dogs their hearing is ultrasound. Okay, better than us. All right. So ultrasound for some animals they are very useful. Okay, for example, if you look at bats, if you look at dolphins, all right, what do they use ultrasound for? Ultrasound is used by some animals such as bats to detect obstacles in front of them. We call it echolocation. All right, you see, bats they are very smart. Okay, they're very smart. So bats they live in the, by the way, bats, they come out at night. They live in the dark. They cannot see anything. Do they have good eyesight? No, they don't. But they use their hearing as the way for them to fly around. All right, so how do bats do this? Okay, bats they will emit an ultrasound out. Okay, emit an ultrasound out. So when the ultrasound hits something, let's say a wall, let's say a predator or a prey or something, so this thing they will reflect the sound back to them. So by how long it takes to come back to the bats, they can roughly know where the object is, where the prey is, where the wall is. So a bat will not fly into a wall. You don't see a bat fly, suddenly they knock a wall and then they die. No, they don't, because they know there's a wall in front. So they will use something called ultrasound. You see, this is a very smart natural design. They just have this, you know, by nature. So they use this ultrasound to detect where the prey is, Okay, by using the reflection, they know where they are. So this is what we call echolocation. Why is it called echo? Echo means the reflection of sound, right? In Mandarin, it's called 回音. Echo, right? When you shout into a cave, the cave will bounce back the sound, right? That's echo. So they use echo to find out where the location of the prey is. So we call it echolocation. So bats, they do this. Dolphins, they do this too. You see, they are very sensitive with this. We don't have this. Okay, but we copied their design. All right, we copied their design. We took their ultrasound and we put it on things that, you know, around us. Okay, for example, we humans use ultrasound. Okay, we stole their technology. Okay, we stole their technology to detect fishes under sea and to view human organs. All right, I don't know whether you have seen this before. Okay, I don't know whether you've seen this before. Okay, fishermen modern fishermen okay, modern fishermen like let's say you are a fisherman in Japan. Do you know fishermen in Japan, they earn a lot of money because they will hunt for salmon and tuna. Okay, salmon and tuna. So how do they do this? They use ultrasound. Okay, they use ultrasound. You think they just simply put a net down there and then they just simply drive the boat around to just catch any fish they want? No, they're very smart with this. So they just emit a sound wave. When they hit a fish, it will bounce back. So the device on the ship, the ultrasound device, will tell them how deep the fish is, where the fish is. So then they can lower their net and then they can catch the fish. You see, very smart design. Okay, very smart design. So this is what they use for detecting undersea. Okay, they also use this to detect where's the sea floor. Okay, you know what's the sea floor, right? All right, I don't know whether you have heard this before. They say, oh, the deepest ocean in Indian Ocean is don't know, 7,000 meters. Okay, let's just say the Indian Ocean. Okay, Indian Ocean, Indian Ocean depth. So have you ever how they get this number? Have you ever asked how they get this number? Like, okay, Indian Ocean is 7,000 meters. Hey, you know how deep is 7,000 meters? 7,000 meters is 7 kilometers, right? Do you think they pull a ruler down to measure? No, they use ultrasound lah. They use ultrasound. So they just emit a wave. So how far does it take for them to bounce back? So they will know how deep the ocean is lah. Okay, you know what's the deepest place in the world? That's the Mariana Trench. Okay, do you know the Mariana Trench? This is absolutely crazy, man. Okay, how deep is this thing? How deep? Okay, let's see. Let's look at the depth. Okay, the Mariana Trench. Okay, 11 kilometers. 11. That's the deepest place in the world. All right. Hey, you know how far is 11 kilometer? I think from your house, you drive 11 kilometer, you are most likely in another taman already. That's the length. Okay, that's how deep they are. That's 11 kilometer. Okay, so how do they measure this 11 kilometer? They use the ultrasound. Okay, so this is the use of ultrasound. All right. Even if you crash your plane, okay. I don't know whether you guys know in 2013 was it? You know the year our plane disappeared. You know MH370, guys. You know MH370. That year we lost 3 planes. If you still remember, we lost MH370, which is still not found. We lost MH17, shot down by the Russians. We lost one more, which is QZ8501. That is an Air Asia plane. Okay, this thing, this one we found it okay, after just a few days. This thing crashed because of bad weather. Okay, because there was I think there was a thunderstorm or something, and then the pilot couldn't handle it, so the plane crashed into the ocean. All right, so the plane crashed into the ocean. How do they find the plane? Okay, on every plane, okay, this is extra info for you. I don't know whether you know, every plane has something called a black box. Okay, every plane has something called a black box. It's not really a black box, okay? We just call it the black box. So this is the flight recorder. All All right, whenever something happens, whenever a plane crash, when they are trying to find the plane, where is it, they will try to look for this thing. Because when you crash your plane, let's say you're a pilot, you crash your plane, this thing will emit a signal out. They will send out a signal. All right, so let's say you crash your plane, let's say here. And let me change another color of the pen. Let's say your plane crashes here. Okay, let's say your plane is here. So the black box is here, right? So the black box will send out a radio signal. All right, so if you're a ship, you're trying to find the plane, you try to detect for this signal. You try to scan for this signal. Once you found this signal, then you will roughly know where the plane is. You will roughly know where the plane is, so it's easier for you to send a team down there to look for the remainings of the planes. All right, so this is the black box. All right, so you might say, sir, then since MH370 has the black box, right, why can we still not find it? Because you see, once you crash your plane, this black box will only send out the signal for 1 month. Around there, around 1 month. You know why? Because this thing has a battery. This thing has a battery inside. Once the battery runs out, okay, once the battery runs out, the signal will stop. Okay, there will be no more signal. Once you have no more signal, it is quite impossible, not to say impossible, but it's very hard for you to find where your plane is. This is what happened to MH370. Until now, we don't know where is it. Okay, we don't know where is it because the black box has no more battery. You know, the thing is mostly crushed into the deep part of the ocean. We have no idea where is it. Okay, until now lah. Okay, until now. So this is what we use ultrasound for. Okay, this is what we use ultrasound for. We use it for fishing. We use it to find whatever that's under ocean. Okay, and of course, we use this in something called sonogram. Okay, sonogram. Have you heard of sonogram before, guys? Sonogram. Not only they are good for scanning babies. Okay, whenever I talk about sonogram, you think of, oh, sir, scan baby, scan baby. No. Sonogram, you can use it to scan anything. Okay, sonogram. Let me search here. Okay, sonogram. Okay, sonogram. Sonogram is we use it to scan your organs. I mean, not only we scan for babies, you can use this to scan your organs also. All right, let's say you have a kidney stone. Do you know what's a kidney stone? If you don't drink enough water, you cannot pee. There's a stone stuck inside your kidney. That is called a kidney stone. So how do they scan whether you have kidney stone or not? They use ultrasound. Okay, they use ultrasound. And then for babies, of course, they use ultrasound. All right, guys, this is not X-ray. Very different. We use X-ray to scan bones. We don't use X-ray to scan babies. You know why? Because X-ray has radiation. You know what is radiation? 辐射, radiation, the radiation from your phone. Okay, so X-ray has very high radiation. That's why for moms, okay, for anyone pregnant, we don't use X-ray to scan for the baby. We use ultrasound because ultrasound has no radiation. That's the good thing about ultrasound. I mean, it's not very clear compared to X-ray. Okay, X-ray is very good. Okay, X-ray is very good. You can see very clearly, but ultrasound you don't really see that clear. Okay, sonogram is not that clear. All right, but at least it doesn't harm the baby or you can just go for MRI but nobody goes for MRI Okay, you know why? Because MRI is very expensive. Okay, MRI is very clear because they can see almost every part in your body. But we don't use this for pregnant women because it's, you know, very expensive. All right, so we use this to detect babies. Okay, how do they know what's your gender? All right, I don't know whether you know this by I think the 3rd month or the 4th month, you can start to know the gender of the baby already. So that time, your mom will go to the doctor. The doctor will scan her uterus, and then they will find out whether you're a baby boy or a baby girl. So that's a sonogram. All right, so you see both in C, okay, and in your medicine, okay, this ultrasound thing, we stole it from bats. We took the technology from bats and then we use it in our daily life, you see. So this ultrasound is pretty amazing. All right, it's a very amazing technology used by the bats. All right, so anyway, let's talk about loudness, shall we? Let's talk about loudness. All right, so a sound wave too loud can harm our ears. All right, as you know, if it is too loud, that means the amplitude is too high. Okay, if the amplitude is too high, that means there's too much energy. Okay, if there's too much energy, this thing can harm your ear. Okay, so let's talk about noise, shall we? Let's talk about noise. So noise, we measure it in decibels. I think I told you this last week. Okay, I think I told you this last week. Where was it again? There. Okay, decibel. We use decibel to measure noise. All right, so let's look at decibel. Okay, so at 140 dB, the sound hurts our ear, and under long-term exposure, it can create permanent hearing loss. All right, so decibel, let's look at this decibel. The threshold of comfort, as the threshold means limit. At what limit we start to feel uncomfortable, that will be here. Okay, anything lower, your ear feels very fine. Okay, 30 is like whisper. It's like when I talk like this. When I talk like this, it's 30. Okay, 30, really soft. You don't really hear anything. So at home, you're hanging out at home, you switch on TV, okay, you just do normal things, that is 40. 40. All right, conversation, as I'm teaching right now, this is 60, roughly 50 to 60 around there. And then 70 is when things starts to get loud. 70 is when you are in a car, when your dad is driving on highway. All right, I know, okay, it differs for every car. If your dad drives a BMW, okay, a high-class BMW, of course it's quieter compared to a Baroda Myvi. Okay, I'm not saying that Baroda Myvi is a bad car, but when it comes to soundproofing, okay, this is why people spend more on a car, because you see, expensive cars, they are made from very good material. They put a lot of heavy, padding, put a lot of carpet underneath your car. So this is why when you sit in a BMW, or any big cars, okay, or Audi or Volkswagen, any big cars, you sit inside on a highway, you feel quiet. Okay, you feel quiet. Have you been on a Myvi before? Any of you here have a Myvi at home? I do. Okay, my sister drives a Myvi. Myvi on a highway, it's not very pleasant. Okay, I'm not saying it's a bad car. Myvi is a very good car. Okay, it saves you a lot of petrol. But when it comes to the noise, wow, a bit very tatahan. Okay, very hard, very tatahan. Why do I say so? Because if you drive with a Myvi on a highway, at 100 kilometers per hour, you will start to hear it starts to become unpleasant. All right, our country speed limit is 110. Do you know that? Our highway speed limit is 110. So when you're driving at 110, it starts to feel a little bit noisy. Still okay, which is around 70. But as you start to go faster, because I drive fast, okay, as you start to go 140, 150, okay, I have a Volkswagen. If I drive my Volkswagen at 150, 160, I still feel very comfy. Okay, yeah, it's a bit loud, but it's comfy. Okay, my Toyota a little bit worse. My Toyota is roughly around 130, 140 is when you start to hear the noise. But Myvi, no, Myvi at 100, you start to feel it's quite noisy already. If you go 140 or 150, wow, a Myvi gets really loud. It's like you're sitting in a tin can, like the thing starts to shake, and then you can hear the road noise. That's when it starts to get uncomfortable. All right, so when you're driving at around 100, that's the sound in your car. All right, short term is okay. If you are in the car for half an hour, okay. But if you are driving to Penang, let's say you are in the car for 4 hours, I'm sure you have noticed this. If your dad drives, all of you, let's say your family, you guys are going for vacation, you go to Penang, if you are in that car for 4 hours, with that noise, that wind noise and the road noise, after 4 hours you get down from the car, you just feel tired and your ear doesn't feel very nice. Okay, it's very noisy. You hear sometimes even hurts. That's because of the noise. All right. So this is why people they spend more on a car, because, well, the more you spend, the more comfortable a car is. Obviously, okay. So this is your road noise. Okay, this one don't need to memorize one. I'm just telling you for fun. Okay, so 75 is vacuum cleaner. I don't know whether you know this. Dogs, they absolutely hate it. Do you know why dogs they hate vacuum cleaner? Because you see, dogs they have very sensitive hearing. Okay, dogs they have twice more sensitivity when it comes to hearing. So a loud noise for you is an even louder noise for dogs. All right. I don't know about your dogs lah. My dogs they are okay with vacuum cleaner. They are not that scared of vacuum cleaner, but fireworks is another story. Okay, whenever it's Chinese New Year, you know, Bai Tian Gong, the 8th day or the 9th day of Chinese New Year, where Hokkien they burn crazy amounts of firecracker. Oh, that's when my dogs will go crazy. Okay, my dogs will be so scared. They will be like, is it a war already? It's like a war zone for them. Okay, so they will be very uneasy. So you know this lah. So because they have very sensitive hearing. All right. So this is like vacuum cleaner 75. So 80, this is where your ear starts to hurt. 80 is where your ear starts to hurt. This is like what? Noisy restaurant. Okay. Window air conditioner. What is a window air conditioner? This is the last time old unit of air conditioner. I used to have this at home when I was a kid. Okay. Window air conditioner. Have you seen this kind of air conditioner before? They just open a hole at your window. Okay, let me see if I can find this. There. This is the one. Have you seen aircons like this? Have you guys seen aircons like this? When I was a kid, okay, I was born in 1991. Okay, so when I was a kid, when I was like 5, 6 years old, I still have this at home. This thing is really noisy, like stupid noisy. Okay, and the thing is right outside your window, so you can hear it very clearly. So it's very stupid noisy. So even you switch this on, yeah, your room will be very cold, but it will be very unpleasant to sleep because it's very noisy. Okay, so this is your window air conditioner, and of course heavy traffic. Okay, lawn mower. I don't think you will sit beside a lawn mower lah. You know how loud they are. This is where it starts to hurt, because it says here sounds above 85 decibels are harmful. They are bad for your ear. You will cause some sort of hearing loss. You will damage your ear. Okay, and guys, do you know that long exposure of loud noise can actually cause cancer. I'm not joking. I'm not joking. This is why nobody stay besides highway. Okay, do you know something called a highway sound barrier? Okay, sound barrier. Okay, I don't know whether you live near a highway. Most of us don't. I hope you don't lah. If right in front of your house is a main road and it's very noisy, I suggest you to switch house. I suggest you to move. I know it's crazy. Okay, sir, you did change out very easy, man. But hear me out. You see, if you are in front of a very busy road, the long-term noise will affect your sleep, affect your rest, and they will affect your mood. You will feel very stressful. Noise will cause stress, and stress will cause cancer. This is why noise pollution will cause cancer. This is why have you seen this before? So next time when your dad drives nearby a highway, if next to the highway there are houses there, they will build this thing. Okay, this is what we call a noise barrier. This is to block the noise from the road from going to the house. I mean, you don't block it 100%, but at least it's something. At least if you stay beside the highway, it's not that noisy. All right, so next to any main highways, if there's a house, you will see this kind of barrier one. Okay, I think in Subang Jaya they got. Okay, if you go on Kesas, if you know where Kesas is, before you turn into USJ, there's a big, sound barrier over there. This is to stop the sound from going in. All right, because like I said, long-term sound, long-term noise, they will create stress and you will get cancer. This is why rich people, they like to stay quiet place. Have you noticed this? Have you noticed it? I mean, if you are rich yourself, then you know lah. So your dad or your mama, they will buy somewhere very close to forest or whatever. Then you want to stay there. Okay, so because it's very quiet. So because long-term noise is not very good for your health. All right, so let's look at what is above 90. 90 is like subway. You know, it's your subway, your LRT. You try and stand next to LRT, you understand. Okay, you stand next to an LRT, the train track sound of grong, 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 sound, that's 90. Okay, I have a student last time, she stayed right next to it. Okay, she stayed right next to it. Every day, she hear like, I don't know how many times the train passed through. So I asked her, are you okay with this? Okay, she said she got used to it already. But of course, in long term, it's not very good for health lah. Okay, so anyway, so that's 90 something. And then around 100, that's your motorcycle. Okay, boom box is the big speaker. All right, 100 is around, that's a school dance. Okay, 100 something, that's your chainsaw. You know, it's a chainsaw, the thing you use to chop your tree, the thing you use to cut your tree. That's 100 something. Okay, a leaf blower. This is a rock concert. 120 is your rock concert. Have you been to a concert before? Okay, maybe you guys are still young lah. You have not been to a concert before. I have been to a concert before, and I stood right next to the speaker. Okay, I was once like I was in. Have you guys heard of Hardwell? Hardwell is a DJ. Okay, I've been to the rave in Singapore. All right. When I was there, because there's nowhere else to stand, I stand right next to the speaker. Okay, the thing is around 120 lah. So for that 2 hours, I just keep hearing the boom, 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 boom right next to me. Okay, and then after the concert ended, when I go out, when I talk to my friend, I keep hearing this sound in my ear for 2 days. Okay, because my ear is somehow damaged by that, although it's temporary lah. Okay, so my sound is damaged by that speaker. Okay, really unpleasant, but okay, I was young, so I don't care. But it's not very good for you lah. It's not very good for you. I mean, once in a while it's okay lah. Or you go to a sports crowd. Let's say you go stadium, you're watching a football game. That's at 120. And then of course a stop, a car race. Okay, when you're in the car race, it's 130. 140 is gunshot. Guys, if you are playing with a gun, please wear an earmuff. All right. If you are practicing, I mean, if you get to shoot a gun, if you're at a shooting range, have you seen? I don't know whether you watch any movie those police officers when they are practicing shooting at a shooting range, they will wear that earmuff because gun is very loud. Okay, even pistol is loud enough to make your ears hurt. That is only pistol. You haven't include machine guns, snipers. If you don't wear earmuff, you will go deaf. Not even joking. Okay, so if you are in a shooting range, please make sure you wear an earmuff. Okay, so anyway, so that's your noise that's your sound. Okay, that's your sound. Don't memorize this for exam, please. This is not coming out. Okay, please, this is not coming out. All right, anyway, so this is just for fun. So what is an oscilloscope? Let's finish this. Oscilloscope is a device. You use a screen here. This is to let you see sound wave. Okay, remember just now last week when I say sound wave, right? How do you measure amplitude? How do you measure frequency? All right, we will use something called an oscilloscope. All right, I don't know whether you have seen this in school before. If your teacher is not the lazy type, maybe she should let you see this. Okay, but it's nothing, nothing really interesting. It's just a screen connected to a mic. So when you speak to a mic, then you can see your sound wave. All right, so an oscilloscope is an instrument which allows us to see sound wave. All right, the most common oscilloscope, we call it CRO. Okay, cathode ray oscilloscope. What the hell is this? Okay, you don't need to know this. You'll learn this in physics in year 10 or 11. So this is the sound wave. Okay, so as you can see, this is the amplitude. Okay, this is the wavelength. Okay, so that's all. All right, that's all. So as I said, it's a really easy chapter. It's a really easy chapter. Nothing really much to say here. Okay, so anyway, let's go to our exercise, shall we? We haven't done any exercise last week, isn't it? So let's go to our exercise. Next week, we might go to a new chapter. Okay, although we haven't entered September yet, but we will go into a new chapter next week. All right, so number one, write down whether each of the following statement is true or false. So A, sounds are produced by sources which vibrate. True. Like I said, vibration will produce sound. Okay, when you are speaking, your voice box here is vibrating. Okay, you look at all instruments. Every instrument, every musical instrument is about vibrating. Guitar is vibrating the string. Okay, it goes on. Any of you watch orchestra? Any of you watch orchestra? There's the 4 sections, right? You have strings, you have percussion, you have woodwind, and you have brass. Okay, so all of them is vibrating something. Piano is concussion. Okay, when the hammer hits the string, then the string vibrate lor. See, vibration. When you are blowing a trumpet, a trombone, a French horn, you are vibrating the air inside. Vibration also. When you are playing a violin, a viola, a double bass, a cello, you are vibrating the string. Okay, same thing. Woodwind like oboe, bassoon, flute, piccolo are things that you are also vibrating the air. So everything is about vibration. Okay, when you have vibration, you produce sound. Okay, as easy as it sounds. All right, anyway, B. Sounds are carried by air, which moves from sources to our ear. True. Air is the medium. You need the medium to move the sound to our ear. Okay, so that's your medium, which is the air. So C, the frequency of a sound is the number of vibration each second. Yes, true. All right, like I said, this one you don't really need to know too much lah. You will learn this in physics next time. Okay, so vibration per second. Okay, how many times per second? That's the frequency. How many times do you do it per second? That's the frequency. Okay, I know it sounds, answer very confusing. It's okay. You don't need to know this. Okay, so D, a sound with high frequency is louder than the one with low frequency. Is loudness about frequency? Is loudness about frequency? No, this is false. Why? Because loudness is about amplitude. Okay, high amplitude, loud. Small amplitude, soft. Okay, so the high is the amplitude. So E, sound can travel through solid, liquid, and gas. Yes, true. That's the medium. Sound can travel through vacuum. No, that is false. All right, sound cannot travel through vacuum because space has no sound. G, sound waves traveling down the ear canal push on the cochlea. Does it push on the cochlea? No, it pushes on the eardrum. Okay, so this is false. Okay, it pushes on the eardrum. Okay, anyway, I hope this is easy, because this is easy. Okay, anyway, number 2, loudspeaker A vibrates 200 times each second. Okay, what does it mean by 200 times each second? That means 200 hertz lah. That's the frequency. All right, like I said last week, frequency, we use the unit hertz. Okay, 120 hertz, that means it vibrates 120 times per second. Okay, please change this out. There's a typo here. Wait. Oh, 20, sorry. Oh, I did wrote it correctly. So 20 hertz means they vibrate 20 times per second. Okay, so same thing here lah. So if it is 200 hertz, that means they vibrate 200 times per second. So loudspeaker B vibrates 400 times per second. So that's 400 hertz. That means this is high pitch, like this is low pitch, like oh. So high pitch here lor. All right. So what is the frequency of the sound produced by loudspeaker A? Give the value and the unit. So frequency is 200 hertz. All right, 200 hertz. So B, Which loudspeaker produces the note with the lower pitch? All right, so lower pitch would be your loudspeaker A. Okay, because lower pitch here, 200 ma. So C, a ruler vibrates 70 times in 20 seconds. What is the frequency? Okay, so because this is per second, right? Each second, right? So if you want to find 1 second, so that's 70 divided by 20. So this will be 3.5 hertz. Okay, 3.5 hertz. So the frequency is 3.5 hertz. That means 3.5 times per second. 3.5 times per second. So that's the vibration. Okay, that's the sound. Guys, I hope you understand. I hope you understand. Are you guys still with me? Why is the chat so quiet today? Are you guys okay? Are you guys listening? Make sure you are. Okay, don't fall asleep, please. Okay, so this is your frequency. Okay, so this is your frequency. Okay, anyway, I don't know whether you guys heard of something called resonance. I don't know whether your school taught this. This is actually not in your syllabus. All right. Have you ever seen someone? Okay, if you watch cartoon, I'm sure you have seen this. Someone sings until the cup breaks, until a glass cup like cracks. So what is that? That is what we call resonance. Okay, what is resonance? Resonance is your sound. When you sing when two frequency they match, they will go maximum amplitude. Okay, now what do I mean? Let's say if I sing with 200 hertz, let's say I sing 200 hertz. If the glass is 200 hertz, if we match 200 hertz, both of us will vibrate at the maximum. So when we vibrate at maximum, my glass will vibrate very quickly and it will crack. That is resonance. This is sound. Okay, this is sound. Next time you'll learn this in physics, okay, which is the resonance. Very interesting concept. Okay, anyway, so number 3, the diagram below shows an apparatus set up to study the characteristic of sound waves. Okay, so this is to study sound wave. So you have your bell jar here. Okay, this is to the vacuum pump. So I guess you can see where they are going with this. So A, what can be observed when only the bell's switch is on? Okay, if I switch this on, if I don't switch the vacuum pump on, there is still air inside, right? When there is still air, you can vibrate the sound out. Okay, because there's medium here. There is medium here, so you can still hear the vibration. So we can say the bell can be heard. Okay, you can hear the bell because there's air here. And then B, what can he observe when the bell and the vacuum pump are switched on? Explain your answer. So when you switch on the vacuum pump, all the air will be sucked out. Now there's a vacuum inside. So the sound will be silent. You will not hear anything. All right, so what can he hear? Okay, so he can hear nothing. All right, nothing is heard. Explain your answer. Because sound cannot travel through vacuum. Sound cannot travel through vacuum because there's a vacuum here. Sound cannot go out, so you hear complete silence. All right, so we hear complete silence. Okay, so it's completely silent when it's vacuum. So C, what is the characteristic of the sound wave that can be learned from this activity? You can actually write back the same thing. You can actually write back the same thing. Sound cannot travel through vacuum. Or you can say sound requires a medium to travel. All right, you need something in the middle. We call it a medium. So you need a medium for the sound to move through. So D, state 2 characteristic of sound waves. Okay, so what is sound wave like? Okay, so like I said, they need a vacuum. They need a medium to travel. All right, you can actually write back the same thing. Okay, I'm just lazy lah. Needs a medium to travel. They travel the fastest. You can say that fastest in solid, slowest in gas. All right, this is from last week. Like I said, sound is the fastest in solid because the atoms are very close. Okay, liquid is a bit slower because they are now further. Gas is very fast, so it's very slow. That's why you hear echo. Okay, that's why in gas you hear echo. Okay, so understand, So next, let's look at E. Let's look at E. The speed of sound wave. Wait, I think there's a typo here. Sorry, let me change a bit. There's a typo here. Is the speed of sound the same when it travels through solid, liquid, and gas? Explain your answer. Okay, of course, no. Okay, no. Why? Why is it different speed? Because different medium has different densities. Do you still remember what is density? Density means how close they are. Okay, density means how close they are. If they are very close, that means density very high, they are very dense, so they travel very fast. Density very low, they travel very slow. All right, so different medium has different density. So you can add one more point. The higher the density, okay, the higher the speed. All right, the higher the speed of sound. Okay, so higher density, they go faster. Okay, so next, when the tuning fork is hit, okay, this is the tuning fork, it moves side to side and cause the surrounding air molecules to also move side to side. So this is the sound wave lah. Of course, sometimes they don't draw it like this. Okay, sometimes they draw it in this. Okay, it's the same thing. This is the closed one is going up. This is going down. This is going up again. It's going down again. So sometimes they express in this way rather than this. It's the same meaning. It's the same meaning. So the following shows the moving pattern of the air molecule. What happens to the air molecule in X and Y? So here, this is actually not your syllabus, but I can let you know. So this part is when the air molecule, they are far apart. Whereas Y, they are very close together. Right, close together. That's why you have a graph like this. Okay, so which region has a denser air molecule? Which region has less dense? Denser is when they're very close, that would be your Y. Less dense is very far, that would be your X. Okay, this is a little bit out of syllabus, but anyway, it's okay. So number 4, the table shows the speed of sound varies with the substance of different density. Okay, so let's look here. As you can see, if the density is very high, okay, if the density is very high, then the speed of sound is very fast. Whereas in air or oxygen, the density is very low, the atoms are very far away, the speed is very slow. You see, speed of sound in air is very slow compared to like aluminum. You see, this is crazy fast. So take the statement, the speed of sound increase as density increase. So when density increase, speed of sound increase. All right, yes, this is true. B, the speed of sound is greater in less dense substance. Of course, no. Okay, this is wrong. Okay, less dense should be slower. And then next, the speed of sound is greater in metals than in gas. Metal faster, gas slower. Yes, true. And then number 3, the speed of wait, I think I take the wrong one. Okay, number 4, the speed of sound is greatest in densest metal. So is the densest? This is the densest. Is it the fastest? No, it's actually slower. Don't ask me why. This is not your syllabus. You're not learning this. Okay, I'm just trying to, let you understand here. So B, explain the conclusion in A based of the nature. You know what? We skip this. Let's skip this because this is too long to write. All right. Some of these questions, guys. Some of these questions, I took it from year 10. That's why they look a bit hard. Like, sir, why is it so hard? Because they're from year 10. All right, anyway, so C. The speed of sound wave will change when traveling through different mediums. State the relationship between speed of sound and temperature of air. You know what? Let's skip this because, sir, how is the speed of sound related to temperature? You're not learning this. Okay. Oops, sorry. This is not supposed to be a syllabus. So D, Pak Abu uses a hammer to strike one end of a long iron pipe. Ali stands at the other end of the pipe and hears two sounds. Okay, he hears two. When you knock iron pipe, hear the pang sound, right? He hears two pang, 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 two sound. The first sound is heard almost immediately. The second sound is heard 1 second after Pak Abu first strike. Why does Ali hear two sounds instead of one? Explain your answer. Right? So the first sound he hears is from the solid, because sound travels very fast through the pipe, the solid, right? So that's the first sound. And then when Pak Abu hits the pipe, the sound also travels through air. Air is slower, right? So it reaches Ali's ear slower. So that's the second sound. Okay, so why is it one? Okay, so the first sound travels through the metal pipe, okay, which is solid. And then the second sound travels through air, which is gas. So we can say that sound travels faster in solid than liquid. Sound is very fast through solid than liquid. Like I said, if you ask your sibling to go to the other side of your house, to go to the back side of your house, you put your ear to the ground, you ask your sibling to step on the ground, immediately you can hear the sound. All right, because sound travels the fastest through ground, okay, through solid. So that's why Ali hears the first one first, through the metal pipe first, and then the second, the echo is from the air, because that's the slower sound. Okay, so number 5, let's finish this. High frequency is when you have high pitch. Okay, they give you 4 choices here: high pitch, low pitch, loud sound, soft sound. So frequency, low pitch, you have low pitch. And then amplitude, large amplitude is when you have loud sound, right? Loud sound. Small amplitude is when you have soft sound. Amplitude is the loudness, frequency is the pitch. Okay, I'm sure you know this. So the following shows the sound wave generated by musical instrument. Take the diagram that shows the sound with the highest pitch and loudness. Highest pitch and loudness, that means the loudest and the highest frequency. That would be this. You see, very high frequency, very high amplitude, very loud, very high frequency, because it's very close together. So this is very high pitch and very loud. Okay, so describe your choice. Okay, because it has the highest frequency and amplitude. Okay, highest frequency and amplitude. So that's your C. So next, the diagram shows pitch of sound produced by 2 tuning fork, P and Q, same loudness. So predict the oscilloscope trace of the sound produced by tuning fork Q to describe the sound frequency. Okay, so as you can see, this sound here, the close here is the top part, close is the top, close is the top. So you see this. So this one, the close one is here and here. So your wave will look like this. Okay, will look like this. So please make sure they are the same height, because it's the same loudness. But when it comes to pitch, this is low, this is high pitch. Okay, because you see high frequency. Whereas this one low frequency, they are very far away. This one is low pitch. Maybe this is a G, this is a C. Any of you learn music here? This is G, this is C. Okay, because it's higher pitch in your C, in your G. So based on this activity, explain the meaning of frequency is the number of vibration per second. Okay, how can the pitch be compared? So who has higher pitch? So we can say P is higher pitch than Q. I'm just writing it in short form here. So state the difference between sound P and Q. Same answer, I guess. It's the same answer. P is higher pitch than Q. So the last question, why are the two tuning forks hit at the same loudness? Why do they have the same loudness? Because they have the same amplitude. All right, they have the same amplitude. So same loudness, but different pitch. This is higher pitch. This is lower pitch. All right, so guys, I think I'm going to stop here. The remaining answers, I will give it to you next week. Okay, and next week we shall go to a new chapter as well. All right, so I hope you learned something new today. I know this is a very simple chapter. I still hope you learned something new today. I will see you again the same time next week. Okay, so we should have a happy Tuesday. I will see you again next week. All right, so see you. Take care. Good night and bye-bye.